consider, what is this? Number 9, it says sine inverse of negative 1/2, right? So when you say sine inverse of negative 1/2, what we know so far is this, right? That, first of all, we can put this as such, right? Step number 1. What does it mean? Well, first of all, when we say sine inverse of negative 1, it means what? What angle, measure, right? What angle will have its sine value equal to what? Negative 1/2. Right? So that's what it means. When you say sine inverse of negative 1/2, we can say that what? It means what? What angle will have its sine value equal to negative 1/2? So with that being said, we can say that what? Let your theta, typically your Greek symbol or Greek letter symbol for angle, is equal to what? Sine inverse of negative 1/2. And then after that, what we're going to use is the following, okay? What we know is this, right? That if you have a inverse of the function and the given function, the composite of that will be equal to x. So with that being said, we can say that what? Sine inverse of sine of x is equal to x. And that's the same for the rest, okay? You can also say that what? Sine of its inverse is equal to x as well, right? So with that being said, let theta is equal to sine inverse of negative 1/2. What I'm going to do is to get the sine of both sides, right? So we're going to do what? Sine theta is equal to sine of sine inverse of negative 1/2, right? Which means that these two will cancel out, right? Because they're inverses, then we can say that what? What angle will get the sine theta equal to negative 1/2? Well, first of all, what quadrant will that be? Where is your sine negative? Okay, look at your angles in here. So as you may notice in here, the range is only for what? Negative pi over 2 to pi over 2, right? Sorry, I forgot that negative pi over 2, right? So which among those will we consider? The quadrant 1, the 0 to pi over 2, or the quadrant 4, negative pi over 2 to pi over 2, or negative pi over 2 to 0, right? Quadrant 4, right? So with that being said, we are considering quadrant 4, right? Actually, the coterminal angles for quadrant 4, right? So with that being said, what do you think will that be? What theta will lead to negative 1/2? Is it pi over 3 or pi over 6? Oh, we only have like 2 options, right? Sine will be where? 1/2 or negative 1/2 where? At negative pi over 3 or at negative pi over 6? Anyone there, guys? Let's see, right? Is theta equal to negative pi over 6? And let's verify that one, okay? So, let's go to our Desmos and see, okay? If we go to Desmos, look at the, what? Angles in here, right? And let's see where that one is, right? Where your y is what again? Negative 1/2, right? So where is that one? Y equals negative 1/2. Okay, we're looking at the unit circle, right? So where's the unit circle? So r equals 1. That's the unit circle, right? So where is your y equal to negative 1/2? We put in here y is equal to what? Negative 1/2, because that's sine, right? Good. What angle are we looking into in here? So again, that's our unit circle, right? Where's negative 1/2? There it is, right? Well, what angle was mentioned in here, right? So if we highlight this one, we notice that this one is where? There, right? And what is that angle? 11 pi over 6 in quadrant 4, right? But since on our domain it says negative pi over 2 to pi over 2, we're going to get the negative coterminal angle of that, which is what? Negative what? Pi over 6. Good. So if we notice that triangle in here, okay, this is your negative 1/2, which is the sine inverse. Are we good, guys? Right? Now let's see. We can verify if that's actually correct. So what do we do in here? Put in the following, right? Sine inverse. So let's put in here functions. Where's that? Sine inverse of what's that again? Negative 1/2, right? It says negative 0.5235 and so on, right? Is it the same as negative pi over, what did we get? 6? Are they the same? Got it, guys? Right. So we can actually verify from our calculator if we got the same answer, right? It's just that if you plug it in your calculator, again, make sure this is radians, by the way, while doing that one. It's going to give you a decimal answer, but again, it needs an exact answer. In short, an answer in terms of pi. We good? But again, you can verify that in fact, sine inverse of negative 1/2 is actually equal to negative pi over 6. Are we good, guys? All right. Now, let's consider this second question, all right? So, we are looking for the angle theta for such, right? So, again, we're looking for that angle theta. So, what do we do first? Step number 1. Verify which one is the opposite, adjacent, or what's the other one? Hypotenuse, right? Based from the given. So that is your angle theta. What do you think is 12?
Opposite.
Opposite. Very good, right? So check, we got the opposite. What is, what's this? 19.
Adjacent.
Adjacent, right? So check, this is adjacent. Okay, and then after that, step number 2. We're gonna use our mnemonic, right? So let's use our mnemonic. Are we gonna use the so, ka, or soa for such, right? Again, we are given O and A. Which one do we use? So, ka, or toa? Again, we are given opposite. And also we are given adjacent, right? So, which one? Okay, so let's use that one, right? So from the mnemonic, step number 3. Okay. Use inverse, right? To get the angle, right? To get the angle measure. So let's see how we're going to say inverse. So for that one, by the way, so since you're looking for tangent, we say what? Tangent of angle theta is equal to what? Opposite, which is 12, over adjacent, which is what? 19. Okay. And again, what we is saying here, step number 3, use inverse, right? So what do you do in here to do inverse? You're gonna put this on the other side and make it what? Theta now is equal to what? Tangent inverse, right? Of what? 12 over 19. Are we good, guys? Get it? What we did? Right? So again, we're getting the what? Tangent inverse of 12 over 19. Now notice, what kind of angle is theta, by the way, in here? Is it acute, obtuse, quadrant what? 1, 2, 3, or 4?
Acute.
It's an acute angle, so you always know that it's quadrant 1. Are we good? Right? So again, we can just plug it in your calculator and see what the measure is. What's this again? Tangent inverse. Click on functions, click on tangent inverse, and plug in the following. What's that again? 12 over 19. Are we good, guys? Right? Now, considering if the answer is in degrees, how many degrees is that? It says in here. 32.28 degrees. Are we good? So we can say in here that theta is approximately how much? 32 point, what's this again? 28 degrees. Again, if you want to consider the answer in terms of degrees, round it off to the hundredths place or 2 decimal places. Okay? Again, do not forget, click on degrees to get that value. Got it, guys? Okay. So once again, there's a function on our calculator that has the sine inverse, cosine inverse, and tangent inverse, alright? Alright, this one is our last. Oh, let's read this one. How we're gonna do this one, alright? Krish, go ahead. Of cosine inverse. Alright, so how do we do this one, right? So there's a tangent of a cosine inverse. What do you think should we do with this? Okay, first step that we're gonna do is this, okay? Step 1. Alright. Jaden, let's read step number 1.
Look at your function.
Consider
Consider it
right triangle, alright? So, we're going to consider this inner function. It says what? The cosine inverse of 1 over square root of 5, right? In short, bless you. What does it mean? We're using this triangle cat because it's cosine, right? Are we good? Right? So with that being said, if we draw that right triangle like such, okay, and say this is your theta for this inner function, okay, then where do you think is 1? If this is angle theta, where do you think is 1? Bottom, right, or the top? Again, that's cap. Cosine is adjacent over hypotenuse, right? So therefore, where do you think is 1? Bottom, right? Very good. So 1 in here is the adjacent side according to that theta, right? So this is the adjacent. What do you think is that square root of 5? The top or the right? The top, right? So this one is your square root of 5 because that is the hypotenuse, right? Again, cosine is adjacent over hypotenuse. Are we good? Right? Next, what do we do then after this? Step number 2. Use Pythagorean theorem. Because honestly, in a right triangle, once you got 2 legs, you can get the other leg, right? Now let's compute. What is this? What are we looking for? The opposite side. Get that? All right, let's compute for that. What's that again? The opposite side squared plus adjacent side squared is equal to the hypotenuse side squared. Good? All right, so let's compute for this. What's this then? Opposite squared plus, what's your adjacent? 1. If you square that, it's just itself. If you square that, that will be what?
5.
Just 5, okay? So this and that will cancel out. Okay? Again, use Pythagorean theorem and solve for the other side, right? Solve for the third side, yep, or leg. Typically in a right triangle, they're called legs and hypotenuse. Anyway, so in here, what do you think is the opposite side? Equal to. Well, 5 minus 1, that's 4, and square root of 4 is what? 2. Very good, right? Thank you. So that means opposite side is equal to 2, right? Hence, we can say that this is now what? 8.
How did you know that that was the given angle?
How do we know that this is the given angle? Honestly, that's a good question, all right? So we put the angle in here just for convenience, but again, you can put the angle in there as long as the angle is not a right triangle, right? So again, we just put the angle theta in here as a convenience so that, we can say that from here, if this is your angle, then that means that is your adjacent side and this is your hypotenuse side, right? However, if you decide you put your angle theta in there, then that means this is your adjacent and that is your hypotenuse, right? So again, it just depends on where do you put your angle. Now, with the question of why did I put the angle there? Basically by convenience, right? Because honestly, for me, it's easier to see the angle from this side, right? But again, if you feel like you want the angle to be in here, it's fine as well. It's just that obviously you're gonna flip the 1 and square root of 5 accordingly as well. Are we good? All right. So again, I would say the manner of putting where your angle is depends on you. Which one is more comfortable for you to work on? Are we good? Right. So with that being said, what's our step number 3? Right? But that's a good question. Thank you. Step number 3. use what? The outer function, right? Okay, and so, right? So what outer function are we looking for? Tangent, right? So according to that one, when you say tangent, then you know what? I'm going to use a black marker. Here it is, our black marker. So according to my outer function, again it says outer function already in here, then I'm going to use this triangle that says what? TOA. Get it, guys? Right? And what does it say there? The tangent of angle theta is equal to what?
Opposite over.
Very good, right? Tangent is equal to opposite over adjacent, right? So what's your opposite side once again? 2. What's your adjacent side? 1, right? So therefore, the answer in this case will be equal to 1. Well, 2 over 1, which is 2, sorry. Are we good? Right. Now, Mr. Deal, can we actually just use the calculator for that? Let's see. Alright. So let's go to our Desmos, right? And plug it in here. What did it say? Tangent. Okay. What's next? Cosine inverse, right? Click in here. Click on cosine inverse, right? Of what? 1 over, what's that again? Square root of 5. Are we good, guys? Right? Okay. Please do use that one to verify the answer. Alright? But again, what does it mean? We need the steps to actually see how it goes. Like, what is the meaning of that? What is the meaning of when you say, well, tangent of cosine inverse of 1 over square root of 5 is equal to 2? Well, we know the answer is 2. But what does it mean, right? This is what it means. Right? Get it, guys? Right? So, the steps actually does matter for us to give, a meaning on, that string of trigonometric and inverse functions, composition functions. Are we good, guys? All right. Thank you.